Hello everyone, this is Dr. Lennon. So let's take a look at another linear programming example. So on this one we have a portfolio where we have two projected returns, 18% and 8%. And the investment advisor has some constraints here. So at most, 25,000 is going into this internet fund, which has higher earning potential, but also a higher risk factor. And he's investing $50,000 at max. So the risk profile, what do we have? We have a risk rating of $5 per thousand for the internet and $4 for the blue chip. So, this is kind of funny. I think this might be a typo. It says $10,000. Oh, no, 5. Yeah, this should be a typo on this one because it says if $10,000 is invested in each of the two investment funds, B&R's risk rating profile it says 5 times 10 plus 5 times 10, but it should be 5 times 10 plus 4 times 10 because the blue chip is less risky. So somehow I think this is a typo. I've done this problem before and the typo wasn't there, so just keep that in mind. Alright, so then we have one last constraint that they recommend that a client who's a moderate investor limit his or her profile to a maximum risk rating of 230. So we want to formulate the strategy. Normally what I like to do is, I'll just pull this over here and then I'll open up Excel and I'll create some kind of organization for it. So we have the fund and we have internet and blue chip, and then let's just try and organize that data that they told us about. So what do we have here? Let's think. Well, we have the annual return. We know that for both. So we had 18%, so 0.18, so I'm going to enter that for internet. What was it for, let's see if I can get it, gotta re-expand this, 8% for the blue chip. So blue chip 0.08. Then we had the risk factors, risk, so this is again per thousand. So 5 here for the internet and 4 for the blue chip. So maybe we'll call this one next to it total risk. And then we should also, I'm going to put this, I'd prefer it over here, maybe the amount invested. So we know that they need to, that's a maximum of $50,000, so well, let's just put some dummy variables in there for now. Let's say 25,000 and 25,000. So this is basically all of the quantities that we're trying to that are involved in the optimization. So the top is like our variables, and down here maybe we'll add the constraint values. So let's say blue chip, internet investment, or internet max, let's call it. This one was 50,000 at most. We also, internet max was 25,000. Total max, most allowed was total max 50,000. There's also a amount allowed, if you remember, on the risk. So maximum risk rating is 230. So we've got max risk, or risk max, however you want to say it, 230. Any other values down here? Maybe, the total risk of each, and then maybe we'll have the sum of the total risk here. So how would we compute the risk? let's start adding some formulas to fill these things out, because that's really what matters. So the total risk is just equal to the amount times the risk value. And then the risk here is equal to the amount, again, times the risk here. And then the total risk is just the sum of these. So we'll say this is oh, I know what's going on. So let's denote, instead of using the thing in since this is per $1,000, the risk is not just those values multiplied together, but what is it? It's those values multiplied together and then divided by 1,000, because it's per $1,000. So let's just divide that by 1,000 to get the value. Because remember, the max risk is 230, and that's what these need to be less than. So that's going to be our constraint when we do the solver solution. So 125 and 100. Basically, when you add these, they've got to be less than this risk max. So we've kind of got everything figured out here. We've got our formulas. So let's take a look and see if that helps us answer these ones down here. So what do we want? If required, round to 2 decimal places. We want to maximize. We want to maximize well, let's maybe some of the ones down at the bottom are easier. I can't exactly remember. Okay, so this one right here is saying, okay, our variables I and B, internet and blue chip, we both want them to be positive, so greater than or equal to 0. Maximum available funds, well, if this is just if you add them together, so 1 times this plus 1 times that needs to be less than or equal to the 50,000. And then the maximum investment in internet, so that's just 1 times the internet, and blue chip doesn't have any effects, so times 0, that needs to be less than or equal to $25,000. So this is basically what we're going to type into solver. And then maximum risk for moderate investor, so that's the 230, so that's the risk rating. So this one, it's 5 for the internet, and 4 for the blue chip needs to be less than or equal to 230. I'm not sure if this is in thousands or not. Maybe this should be less than or equal to 50, and this should be less than or equal to 25. I'm not exactly sure. Let me just do it with 25 and 50. That's the way they probably have it set up, because they've got it in thousands up here. And what do we want to maximize? I'm guessing the profit amount, the rate of return, which should be, if we use the projected values, 0.18 times the internet value plus 0.08 here times the blue chip. So let's check that and make sure that works. Okay, yeah, so we got them all right. See, this is really weird. This is coming back to this typo. Something's gone wrong in this problem, because they have 5 here and 4 here, but the problem is they have a 5 here and a 4 here and a 5 here. So this is an error, so watch out for this. So what I'm going to do is I'll take 5 here, and I bet you it comes out right. So I'll do a 5 there. Check the work. Yeah, it likes that value, so that's kind of weird. Alright, then they want to build a spreadsheet model and solve, and what's the optimum investment for the client. So let's go ahead and do that. So we want to solve this with the optimization. So let's add, just for one other thing, let's add the profit at the bottom. So Control B, we'll call this profit, and profit is just going to be equal to 0.18. Oh, the annual return, so I'll do that. So I'll just do the annual return times the amount invested, and then the annual return here times the amount invested. Okay. Somehow, since the risks aren't different, so we're probably going to have to change this to 5, right? Because that's what the problem thinks, because of that weird typo. Again, we want to go to the solver. So that's right here. remember it's an add-in, so if you don't see it, you're going to have to add it in. I've shown you how to do that in a few videos before, so by this point, hopefully you should have that. Again, this is a simple linear problem. None of the variables are ever squared or had anything changed to them. So what do we want to do? We want to maximize... Oh, I forgot to include the total profit, so let's do that quickly. So the total profit is... and again, let me just do it in case the... because the amounts need to be fluctuated. So 0.18 times the amount here plus 0.08 times the amount here, we get that. And then we have the... Alright, so now we can go back to solver. This is what we want to do. We want to maximize, so our objective function is right here. What are the changing cells? Well, the amounts we invest, and now we need some constraints, right? So I think there were three. Basically, the total amount has to be less than or equal to 50,000, so I need to add those up. So the total amount right here is equal to this one plus this one, so that gives me the total. So back to solver. So constraint number one, we need, so I need to click add. We need this one less than or equal to this one, the total max. Add that constraint. What was another one? Well, we need the total risk, again, which I haven't summed, so we need to do that quickly. So this is the total risk, so this one plus this one. That has to be less than or equal to 230, so right now that's not valid. So let's add another constraint. This cell needs to be less than or equal to this cell. And then, what was the last constraint? The internet value can be no more than 25,000, so the internet has to be less than or equal to this one right here. So let me add that constraint. Those are the only three. So now we can just run the solver, and it should find us the optimal value, which it does. It changes them all around, and we get a maximum profit of 6180 when we invest 25 and 21,000. So let's go back to MindTap and enter those. So I think 25,000, 21,000. Then the annual return, I think, was 6180. Check it. Okay, so this checked out. The last two parts I think you can handle yourself. Basically, for C, you just need to change the risk rating max from 230 to 340 for this more aggressive client, and then suppose you have another one that's a conservative, you just change the risk to 150, and then run the numbers, and that should do it for you. Okay, thanks.